Within chemistry, collision theory describes collisions occurring between molecules. Essentially, when two molecules collide with one another, what will happen and how does it happen? That's what collision theory entails. So, collision theory entails three postulates. The first postulate states that the number of collisions is proportional to the rate of the reaction. Now, what does that mean? Let's say I only have 5 molecules. If I only have 5 molecules, the probability of them colliding or interacting with one another is not very high. If the probability of molecules colliding with one another is not very high, then we can understand that the rate of the reaction will be a lot slower because these molecules are not colliding. But if I have lots of molecules, I have so many molecules that the probability of them colliding with one another is very high because there's just so many of them. So in comparison between this set and this set, the probability of molecules colliding is higher for this set and lower for this set. And if molecules are greatly colliding with one another, the rate of the reaction will be higher. So postulate number 1 simply states that collisions are proportional to the rate of the reaction. So if your number of collisions are high, your rate will also be high. But if your collision rate, number of collisions is low, your overall rate of the reaction will be low. Now, the second postulate states that collisions must occur in specific orientations for a reaction to successfully occur. Now, if we have this molecule over here, this molecule has a green end and it has a purple end. This is just hypothetical. Now, we have this second molecule over here in blue. In order for this reaction to successfully occur, this blue molecule must collide with the purple molecule, but the purple end of this molecule. But if the blue molecule collides with the green end of this molecule, no reaction will occur. And why is that? Because according to the second postulate of collision theory, molecules must collide in specific orientations in order for a reaction to occur. So in this reaction, the blue molecule has to collide on the purple end of this overall molecule. If it collides on the green end of this overall molecule, the reaction will not occur. So we have to have specific orientations. Lastly, the third postulate states that collisions must have sufficient energy to form new bonds. So you must have sufficient energy to form new bonds. Why is that? Let's take a look at our energy diagram. And in our energy diagram, we can see we have reactants and we have products. Now, our reactants must collide with enough energy to make new bonds to become our products that we are interested in. Why do we need a specific amount of energy? That's because, remember, we have this activation energy over here. And this activation energy is the hill that these reactants must cross in order to become our products. So if two molecules collide with one another and they do not have enough energy to cross this activation energy barrier, they will not be able to become products. But if two molecules collide and they do have enough energy to surpass the activation energy, then they will go on to become products. Therefore, when you have collisions occur, they must have enough energy to form new bonds because you have to surpass your activation energy. And those are the three postulates of collision theory, where we have the number of collisions is proportional to the rate of the reaction. Collisions must occur in specific orientations for a reaction to occur. And collisions must have sufficient energy to form new bonds to surpass that activation energy.